歡迎大家嚟到由 The Wave 聯同 OASA Hong Kong 協辦嘅 Future of the Space Economy: How to Build Your Own Satellite 網上研討會。整個 webinar 我哋都會進行網上錄影，大家如果有問題嘅話，可以喺 Q&A session 發問。喺開始之前，我哋先睇下 The Wave 嘅介紹片段。
Hello， 大家好，我係 Nicolette。等我同大家介紹下 The Wave 先。The Wave 係一個創新創業嘅共享平台。喺香港有兩個地方，分別係觀塘同埋旺角。喺呢度，我哋提供工作空間，包括共享空間、服務式辦公室、會議室，亦都有熱情嘅團隊支援，為你度身訂造合適嘅租用方案。我哋用心打造一個有活力嘅工作環境，仲匯聚咗嚟自唔同行業嘅創業人士、中小企等，令大家可以透過 The Wave 呢個平台建立唔同界別嘅人脈關係。我哋亦都提供靈活彈性嘅活動場地，舉辦過展覽、座談會、工作坊、大型會議、攝影活動等。我哋目前舉辦超過4000個活動，帶動咗10萬人流嚟到 The Wave。我哋亦都好支持我哋會員嘅技術同埋服務，所以會採用佢哋嘅科技。例如體溫探測機、指紋分析機、機械人、人面識別技術同埋大灣區電子商業登記服務。我哋主張同唔同組織合作，所以我哋嘅合作夥伴除咗係我哋嘅會員之外，亦都有一啲外來嘅公司。我哋非常歡迎大家成為我哋嘅合作夥伴，一齊舉辦活動，提供會員專享優惠，或者以其他方式合作。The Wave 現正推出一站式 webinar 服務，提供活動宣傳、後台設定、活動後期報告，亦都有專人全程協助活動嘅進行，與嘉賓同觀眾互動。呢啲就係我哋以往舉辦過嘅活動啦。我哋設有 webinar 拍攝專用場地，適合各類型嘅拍攝，包括活動宣傳、座談會、表演等等。The Wave 嚟緊會舉辦更多唔同主題嘅活動。歡迎留意我哋嘅 Facebook 最新動態。Let's make things happen。
我哋今日好開心邀請到行內唔同嘅嘉賓嚟到同我哋做分享。事不宜遲，我哋將時間交俾今日嘅主持 Kimberly。
Today's webinar will focus on the topic of cube satellites, or CubeSat for short, and will feature two speakers, Mr. Kimberly Lam and Professor Quentin Parker. I'll start with a quick introduction of both of our speakers. Mr. Kimberly Lam is the Vice Chairman of the Orion Astropreneur Space Academy, or OASA for short, a not-for-profit leadership development academy based in Hong Kong, focused on the new space economy. Professor Quentin Parker is a professor at the University of Hong Kong's Department of Physics and the director of HKU's Laboratory for Space Research. He is an eminent astrophysicist and is known for his work and discovery of planetary nebulae. And with that, I'll hand things over to Hubie.
Thank you, Kimberly. I'm Hubie Lam, the Vice Chairman of the Orion Astropreneur Space Academy. We are a new organization, nonprofit organization dedicated to space. We aim to educate and prepare students and entrepreneurs to meet the challenges and face the opportunities of the new global space economy. So if you put on the presentation, please. Now today, we're going to introduce the topic of CubeSats. And I'll describe what are CubeSats, what is a CubeSat space mission, and how you can be part of your own CubeSat space mission. Before I begin, I want to thank The Wave for hosting us today. They have been fantastic hosts and extremely helpful. I also want to welcome our audience members from the Hong Kong U Academy. So what is a CubeSat? A CubeSat is a small satellite in a cube that measures 10 centimeters on each side. Some other words you will sometimes see is small sat, nanosat, or minisat. These are just words for small satellites. You'll also see sometimes the term CanSat, and that's the same thing, a little satellite in a soda can. And now, so what goes inside a CubeSat? Well, it's actually very similar to what goes inside a smartphone. In fact, a few years ago, NASA held a competition to see if someone could make a CubeSat from a smartphone. And some engineers were able to use parts from a Samsung Nexus phone, put it into a CubeSat frame, like the one in this picture, send it up to space to take pictures. So let's compare the inside of a CubeSat to the inside of a cell phone. First, communications. Your cell phone has technology that allows you to send and receive data. Same with a CubeSat. It sends and receives data from the ground station or receivers. Second, your cell phone has a power supply, rechargeable battery. Same with a CubeSat. It also has a rechargeable battery, but instead of plugging it in because it's in space, it uses solar panels for charging. Third, your cell phone has a bunch of electronics inside, like a miniature computer chip, that allows you to operate and process instructions, do calculations, figure out your location using GPS, for example. Same with a CubeSat. The electronics in a CubeSat is something we call avionics. It stands for aviation electronics. Fourth, when you switch your phone to vibrate mode, there's something in the phone that helps it to vibrate or move. Same with a CubeSat. There's some propulsion engine inside that allows it to move in space so it can go into the right orbit, or for example, face the solar panels to the sun. Or if there's a camera, it will allow it to point it to the right direction. And last, your cell phone has a camera. Same with many CubeSats, not all CubeSats. Many CubeSats do have cameras, but some have other kinds of equipment like remote sensing equipment or X-ray telescopes, even science experiments. For example, some CubeSats may contain bacteria to see how they can grow in zero gravity. So now let's talk about how CubeSats connect you to space. Did you know that since 1999, there have been over 1,000 CubeSats launched into space? And many of them were by students from universities, high schools, middle schools, and even elementary schools all over the world. Now, most of the launches were done by universities in the US, by NASA, and also in Europe by the European Space Agency. But some CubeSats were launched in Asia, and Asian places that have launched CubeSats include China, India, Japan, Korea, Nepal, Philippines, Singapore, Sri Lanka, and many others. Japan has actually helped many countries without their own space programs develop CubeSats and send them to space through the BIRDS program. And here in this photo, you can see 3 CubeSats from Nepal, Sri Lanka, and Japan, which were sent into orbit from the International Space Station. In fact, what's interesting is that the Nepali satellite was developed by 2 graduate students studying in Japan, and these were the first satellites ever launched by Nepal. Students in Nepal have started their own CubeSat education program, and this month they're planning to launch their first Nepali designed and built CubeSat. So some space programs around the world that have promoted CubeSats for universities. These include the US. It has the educational launch of nanosatellite program called the ELENA program. European Space Agency has a Fly Your Satellite program. Canada has a satellite design challenge. And then high schools have also launched CubeSats. In 2013, a high school in Virginia, USA launched the first CubeSat in a NASA mission. From 2016 to 2018, Irvine County in California, there were 6 high schools that where students designed and built and launched 2 CubeSats. And this project was not run by the government. It was actually started by 2 dads who were interested in promoting CubeSat STEM education for their kids. A few months ago in China, a middle school in Shijiazhuang City, Hebei, launched a CubeSat. And also in 2020, in just a couple of months ago, the US Department of Education launched a CubeSat program, education program for US high schools to design and build CubeSat prototypes. You see also in Canada and Korea, they have CanSat programs. So with all this CubeSat activity going on around the world, what can OASA help you achieve? Well, let's talk about the basic CubeSat project. It involves a mission idea or purpose. For example, it could be a scientific research project. It could be something to help the environment, or it could have a commercial purpose. And so anyone can contribute to that mission idea. Next, you have a design and build phase where you need people with engineering expertise, mechanical engineers, electrical engineers, aerospace engineers. And then if you're able to get through those two processes, then you move to the launch phase. Now, launch is very expensive, very difficult to achieve because there's lots of regulation and insurance involved, but it's also very exciting because then you can actually send your CubeSat into space, operate it, and carry out your mission. Finally, at the end of the mission life, there's a conclusion where you deorbit the satellite and clean up any debris left behind. And again, don't forget all the laws and regulations and licenses involved. For example, in Hong Kong, there's an outer space ordinance that requires licensing for all launches, as well as the telecommunications ordinance for radio communications. And then internationally, there's the Outer Space Treaty of 1967, which provides a legal framework for international law, and then several United Nations organizations under it. And so you can see with all the space activity going on around the world, space law and regulation will be growing in the future. So what about in Hong Kong? Where is it going? Where's the space economy in Hong Kong going? Well, in 1991, Hong Kong made history when AsiaSat launched the first satellite into orbit. And it became and it was broadcasting satellite television all over Hong Kong. Today, satellite TV is available everywhere. In July this year, the Lobster Eye X-ray satellite was launched. It was successfully launched and it made history. The project was co-led by the Hong Kong U's Laboratory for Space Research. We have a representative, Quentin Parker, here. And the future economy of the world is in data. That's called the new gold. So satellite data is very valuable. And it is expected that in coming years, there will be many opportunities for people who are involved in the space industry. So here's some list of space careers and opportunities to keep in mind. We're running out of time. So let me just say a couple of words about the OASA. We connect you with the space economy through our university partners like the Hong Kong U Laboratory for Space Research and other universities. And our plans in the future for space education is through CubeSat education. We want to hear from you. What are your ideas for a space mission? And in the coming months ahead, we will roll out, we hope to roll out CubeSat design and build collaborations and competitions. So please contact us and tell us what is your space mission idea. Here's some contact information. And then I'm going to hand it over to Professor Parker. He's an eminent astrophysicist, as Kimberly mentioned, and we're very excited to hear him describe his work and,
Thank you, Hubei.
And the Laboratory of Space Research. Thank you.
Okay. Thank you very much, Hubei, for that very interesting introduction into the world, well, the outer space world of CubeSats. And as the founding director of OASA, Greg Lee, has said, space is a very dangerous and hostile place, as you can clearly see here. But I broke my collar working on, no, I didn't, I broke it playing football. But anyway, never mind. I'm going to talk about the Laboratory of Space Research, give you an introduction to it. And in fact, we're about to start next year, our very first major CubeSat mission. It's going to be a 6U, which means that of those 10 by 10 elements that Hubei mentioned, we're going to have 6 of them, 3 by 2 in an array, to do MEV, gamma ray telescope, so another science mission. But I'll maybe talk about that a little later if we get a chance. But to start with, I'm going to introduce the Laboratory of Space Research. Now, these are prescription sunglasses. I forgot my clear one, so I'm not doing this to look cool particularly. It's because I need to read my slides. So please understand that. So anyway, the mission of the LSR, we've only been going for about 3 years, is to emerge as a leading interdisciplinary research center in space and planetary sciences across the Greater Bay Area with a strong identity. So you can see our link there. You're welcome to check out the link anytime. The second mission statement is to maintain and grow the LSR so that we're internationally recognized as a solid brand of research excellence in mainstream space and planetary sciences. And our third mission statement is basically to strengthen and develop our ties, in particular to the Chinese mainland, because that is where the burgeoning space economy is really going gangbusters. That's where, for us, in the GBA, the future is likely to be. Doesn't mean we're not connected internationally to other areas. We are, with partners like Padava-CISAS, one of the strongest satellite groups in Europe, and the Natural History Museum in London, which has one of the best meteorite collections anywhere in the world. So anyway, we're nothing without our members. It'll be the same for OASA. It's the membership of OASA and the LSR that actually means something. This is where the human capital is. This is where the ideas come from. The effort is generated. So that's just a little picture slide of all our members. I'm in there somewhere. We've got, actually, we've gone up in the last week. We've got 54 members now across 5 different departments and 2 faculties at the University of Hong Kong. So we're interdisciplinary in the truest sense of the word. But we're a free association. No one's forced to be a member. It's perfectly okay if you don't want to be a member, even if you're an astrophysicist at Hong Kong. We have 1 or 2 of those. No, that can't be right. 5 minutes left. I better hurry up. So these are some of our partners. As you can see, what we've done at the LSR, strategically connect up to the very best entities we can globally and in the mainland. And so we're very targeted in who we work with. And that's delivering strong dividends to us right now. Oops. So this is just a slide that Hubei mentioned, the incredible growth of the space global economy. And as Morgan Stanley predict, they'll be worth over $1 trillion by about 2037. So we're really entering the era of the space economy in every sense of the word. The satellite that we're associated with, it's a 73 kilogram satellite. So it's not a CubeSat, it's a serious satellite, 73 kilograms. It was launched on July the 25th, a very large field of view, and it's designed to look for something called a sterile neutrino, which has an X-ray signature in a low energy range. So this is part of a called the Dark Matter Explorer, is another name for this satellite, and it uses a novel X-ray focusing technology based on the way a lobster eye works. And it's the first commercial space science satellite in China. It's the first payload for soft X-rays and the first one to use lobster eye technology. So that's a picture of the satellite. We have a model in our laboratory of space research, but that's the actual satellite itself, it being finalized in Shanghai before it's shipped to Beijing and then onto the launch site to the west of Beijing for launch on July 25th. So that's the instrument. It's based on focusing X-ray camera with quite a wide field of view over a modest energy range. And there's sort of a little bit of detail there. More of information can be found on our website. But basically, it's all about trying to find the signal for dark matter. One of the holy grails of modern astrophysics is trying to understand where the dark matter is. Now, baryonic matter, that's everything we're made of, all the atoms and molecules and electrons and everything of normal matter only makes up a few % of the universe. Dark matter makes up a considerable fraction. And then we have dark energy making up about 70% of the energy density of the entire universe. So trying to understand dark matter is one of the holy grails of science. And I won't say more than that, but we are very interested in this mission succeeding. The satellite's working, telemetry's fine, data's coming in, and we hope to have important research papers coming in the next few years. So that's it there being launched. There's a satellite is inside that fairing at the top of the rocket. And there's a launch videos available on our website if you want to check that out as well. But basically, interdisciplinarity, as I said, is the key. Modern science, modern space science and astrophysics is all around the interconnection between all kinds of different scientific disciplines. We're talking about the electronics, remote sensing, automation, AI, big data, computing, propulsion, metrology. Metrology means measuring things very accurately in terms of having good positions for all the equipment, material science, engineering, etc. So all of these things come together in a heady mix of high technology and brain power to actually create some of these missions that we're talking about. So the main branches of science involve the physics, of course, mathematics, mathematics being the language of science, statistics, because there's so much data now, we have to understand how to filter it, sift it, evaluate it, visualize it, and then use it. And of course, chemistry and biology, because everybody knows about astrobiology, everybody knows about astrochemistry, and these are big emerging fields now. Okay, so the LSI is proud to be one of the founding members of the Orion Astropreneur Space Academy. I think this initiative is fantastic for Hong Kong, and I see a great future for it, and the LSI will ensure it plays its role to the maximum in making sure this endeavor is as successful as I believe it will be. Our university, there's some very good universities in Hong Kong, excellent universities in the top 100 in the world. Hong Kong U is the best place among them. We have the reputation, power, and grasp to partner, as you saw in that partner slide, with the best planetary science groups, space and planetary science groups in the world. We're establishing joint labs with top mainland space and planetary science entities. We've signed very powerful MOUs and agreements with National Astronomical Observatories of China, the Shanghai Academy of Spaceflight Technology, the Beijing Institute for Science and Mechanical Electricity, the Chinese National Nuclear Corporation. Oh, that's interesting. Why are we doing that? There's a story there. Zhejiang University, Nanjing University, Natural History Museum in London, Padova in Italy, etc. We bring all of these to Hong Kong SAR and the mainland in terms of our capacity. And we signed in a recent MOU in May with the Chinese Space Utilization Group. They're the ones building the Chinese space station. They're the ones where they can use entire constellations of CubeSats out the backside of that space station. Okay, we've just signed in October an MOU with the East Asian Observatory MOU as well. So that's basically what we hope to do. And that's my last slide. And last thing we hope to do early next year is to have a joint lab with the Chinese Academy of Sciences and the University of Hong Kong Laboratory for Space Research, setting up both in Hong Kong and in the Greater Bay, hopefully in Dongguan. Okay, so that's the end of my sales pitch for the LSR. And so you all want to join now, yeah? Thank you very much. Thank you.
Awesome. Thank you so much for the sharings, Hubie and Professor Parker. That was a fantastic introduction to CubeSats and OASA's mission in general. And I'd actually like to get the ball rolling with a couple of questions, and then we'll actually open the floor to questions directly from the audience. My first question is actually for Hubie. You mentioned in your presentations that I think to date, 1,000+ CubeSats have been launched globally, many of which have been developed by students, which is fantastic. It's really surprising to me that Hong Kong hasn't launched a single CubeSat yet, especially given our close proximity to cheap off-the-shelf components in southern China, and given that we have some really strong universities. What has been the holdback?
Well, that's a very good question, Kimberly. You'll find around the world that many times it's really just individuals coming together and sparking the interest. It's like a catalyst. It may be one person, for example, the two dads I mentioned in Irvine, California. They gathered their contacts in the local industry and foundations to contribute resources and volunteer their time to start these CubeSat programs. Similarly, in Nepal, it was students, two graduate students studying Japan, who first got the ball rolling, and then another another young engineer who was living in Switzerland, Nepalese engineer, who decided to teach students online about CubeSats and about space. And then he started this program, which is now planning to launch their CubeSat in December this year. So it's always, I think, interested individuals, like-minded, who want to create that space community. And then they rely very much on experts like Professor Parker and universities. But it's really connecting people in the business community, the universities, and educators.
Got it. Thanks so much for that. And Professor Parker, can you walk us through what's actually involved in developing a CubeSat? It sounds really daunting. Maybe can you walk through the various stages of the development process? And then to add to that, what type of support can I get from HKU and your lab in particular?
Well, that will take me an hour to answer that question in detail. What we do with CubeSats is basically when you design any satellite, NASA and ESA have a whole series of different protocols and phases that you go through. when you're doing a CubeSat, you compress those phases into a much shorter timescale, into fewer phases. But basically, you follow the same kind of process. You also take benefit from COTS, components off the shelf. That's what COTS is. And and so you basically have to adhere to a set of regulations for CubeSat standards, and everything is built around those. But at the end of the day, each CubeSat has something called a payload. The platform's a CubeSat, the payload is what the CubeSat actually is designed to do. Now, R1, which we're going to be developing from next year, we hope to launch it within 2.5 years, is a 6U CubeSat. So it's 3 of those 10 by 10 centimeter elements down and 1 across. So it's 2 across, so it's 6 altogether. 2 of those are the payload. That'll be the gamma ray telescope. 2 are the propulsion system at the bottom, because you need to deorbit, you might need to change orbit. And then, and 2 are all the avionics, the UHF, VHF, and S-band antennas, the onboard computer, the reaction wheel, the GPS system, the magneto-torque, and all these elements go into those other 2. And these are miniaturized, and also the power supply, the battery. We have lithium batteries that get powered by the solar panel so that when the satellite maybe is in an eclipse, you can still power the onboard systems. And so, there's a process that's been developed over many years, and it's getting refined all the time. There's components you can buy off the shelf which are very cheap, but then the actual point of the CubeSat is the key. And that's where the brain power comes in. That's where the ideas are born, is in what you're going to do within this envelope.
Got it. And on the topic of costs, what are the basic costs associated with developing a CubeSat? And, as a student, what are ways that I can get, my projects financed in Hong Kong?
Okay, our project, we're going to finance that through our own grant system and through our partners' own funding. So it's a 1/3, 1/3, 1/3, and it's about 6 million Hong Kong dollars. And that's a lot of that's going on to detectors. But, and we're getting it through, basically through university's own capacity, through our own grant systems. Both Padova Sisters, Zhejiang University, and Hong Kong University are the 3 major partners in this CubeSat at the moment. And so, what was the other part of your question, sorry?
What is the average cost associated
Yeah,
with
well,
if
you're going for a single 10 by 10 by 10, it can be relatively cheap. High schools can potentially even, through fundraising, get one. The launch costs are coming down significantly as well. India launched 100 CubeSats in one hit out of its single rocket that was launched. They all pop out of the fairing at the end. So the amount of dollars per kilogram has gone down a lot. Miniaturization has meant you can do a lot more in a smaller volume than you can do before. So everything's getting cheaper and cheaper, which is why we can do things in the tool. But our CubeSat will cost 6 million. You can do a CubeSat for 2 million, for 3 million. That includes the launch.
I want to add to Professor Parker's, if you take out the cost of the launch, then the component costs are actually very inexpensive. However, to really test them for space and make sure they're vibration resistant and temperature resistant and radiation resistant, all that costs much more. So to go through a process of building a prototype, the components are actually very cheap.
Yeah, but most of those components, if they're actually CubeSat certified, they've already have been certified to be in space. It's how those components are put together within the envelope, and also the thermal, the thermal modeling you need to do. So I can't put that component next to that component, because if I do, that's going to create too much of a thermal issue between those 2 components. So it's the design of how you put all those COTS components together in a way that doesn't compromise the integrity of the mission. So that's where the key is, actually. But it's right, some of them do need to be tested, especially if it's a new component you're designing. But most of the tried and tested components have already been tried and tested in space.
Awesome. Yeah, thanks for that. That's very helpful. Huey, you mentioned in your presentation that CubeSats have the ability to capture meaningful data. Can you tell me a little bit about some of the data that's been captured by CubeSats launched by students in the past, and some of the meaningful applications of that?
Sure. It's a very good question. I'd like to mention, for example, the story of a company called Skybox Imaging. Now, Skybox Imaging started as a project by 4 students at Stanford who were taking an entrepreneurship class, and they planned to take very high quality photographs of the Earth from space using, CubeSats. They developed it, and unfortunately, they found that the cameras at that time were not powerful enough to take these high quality photos. So they used a bigger satellite, not a CubeSat, but still, I think a small satellite. And they were so successful with that project that they sold the company 6 years later to Google for $500 million.
Wow.
Okay, so it just shows you the potential for this type of thing. Another project very recently is something called VR space. So now that technology has improved, a couple of years ago, a company sent up these very high quality, high definition virtual reality cameras that have taken these very beautiful images and video in virtual reality of, from space, and allows people on Earth to experience what being in space is like. And it gives them, even though if they can't fly to space, they can experience the visual effect of that.
Got it.
So it could be used for entertainment, for instance.
Great. I think those are great examples. And Professor Parker, if I'm an educator based in Hong Kong and I'd like to bring a CubeSat development program to my school, where can I find the experts available in Hong Kong who can help me design an effective curriculum and process, and ideally those that have launched successful CubeSats in the past?
Okay, well, as Hubert has already mentioned, the CubeSat industry in Hong Kong at the moment is pretty well non-existent. I mean, we've got a major science satellite, but it's not a CubeSat. We're looking at building one starting next year, so we're gaining expertise. We are partnered with Zhejiang University, who do build CubeSats, and they're the most successful and most important microsatellite research group in any university in the whole of China. So we have a direct conduit to all the expertise at Hong Kong U. And of course, we have our own expertise within the Laboratory of Space Research. Other universities also have some space expertise, like Chinese University of Hong Kong. And there's now the Hong Kong Aerospace Technology Group that was established recently and been raising funds and looking at building CubeSats in Hong Kong, actually. But at the moment, the resource we have here is human capital. The ideas, the expertise we have, in high technologies, in our top universities, in the engineering departments, that's where the expertise lies. I mean, it's all engineering and design, a lot of it. And we do have great engineers and designers here in Hong Kong. We've got great human capital, and that's where the success of the Hong Kong space economy will come from, in my view.
Got it.
Yeah, and just to add to what Professor Parker said, for the teacher that asked the question, I think come to OASA, send us your questions to the email address I mentioned earlier in my presentation. And we'd like to hear from you. We'd like to hear what kind of CubeSat program for education will fit your needs and your students' needs, because everyone in Hong Kong is different, but there's a place in space for everybody. So we want to make sure that we have the right kinds of programs for your students and for the needs of Hong Kong.
I mean, CubeSat's been around a long time now. It's quite developed. There's a lot of missions have been launched, over 1,000. If you're coming up with new ideas after you've got 1,000 of these things out there, it's not easy. We're moving away from, just for a little bit of an educational kick to something that needs to be much more commercial, much more serious, I think, in the future.
Yeah, and one other thing I want to add is Hong Kong's always been a transportation, aeronautics, logistics kind of center. And we have the finance capability, the universities, we have all the ingredients for a vibrant space economy. It's just we haven't bothered to put attention to it.
Correct.
And so I think, now that the space economy is here, it's a perfect time to start getting involved.
Awesome. That's a great ending note. And now we'd like to start looking into questions that have been submitted to us online from our audience.
Right.
And I'll start with our first question. So thank you for your introduction. What would be a typical timeline like if a school or a company is planning to launch a CubeSat? So this is a question about timelines for developing and launching a CubeSat.
How long is a piece of string? If you've actually got your idea finalized, then from starting the project, a proper project, to launching it can be a year. A lot of things are just off the shelf. You just need the right people to put them together in the right order, et cetera, et cetera. But the key thing is getting the ideas right, getting all of that design sorted out before. And that can take a lot of time. And that's really where the trick is. That's where the brain power goes. But getting all of that time can be quite time consuming.
Okay. Our second question. Why do you think Hong Kong has an edge in launching a space program where people tend to think the city is a place only for finance or general applications in terms of entrepreneurship, fintech or health tech as an example? How does space technology relate to our daily life? I think this individual is asking why Hong Kong?
Why Hong Kong? Well, I started mentioning that Hong Kong has always been a center for transportation. If you think of from the days of sailing ships, Hong Kong was a major trade port. Then when it went to steamships, Hong Kong embraced that new technology, and then to air travel. Hong Kong is one of the major air cargo transportation places in the world. We have a lot of aeronautics history here. And when you think about space, it really is just a higher and more extreme location than what we've been doing. And so all the expertise is already there to manage that process safely and finance it. Very important. Financing, extremely important. We have excellent capital markets here for raising funds to finance these ventures. And one other thing that should be interesting to people is the last I heard, the stock market for space companies in China is going back gangbusters. And so it's just a matter of time before that comes to Hong Kong. And I would predict that there will be a Hong Kong listings of space companies in the not too distant future. So it's actually an advantage to be in Hong Kong.
I'd just like to add to that, if I may. For me, it's not so much about the building and the launching, it's about the data, as been mentioned before. It's the data that brings in the finance. It's the data that brings in the money, and it is the rich pieces of gold that we've been talking about. It all comes downstream. So you launch your CubeSat, if it's got some kind of remote sensing capability, you've got the cadence right, you've got the right filters in, you're doing the right kind of imagery, then you're selling that data to a customer to do a specific thing. And so it's downstream data in logistics, in transportation, and we have all of that expertise in data manipulation and big data. We're talking about large amounts of data eventually. And so I think it's the data side of things, which I think is where the money is. And that's, we're a money city. We're a big financial center. And the space economy, as you saw, is going to be $1 trillion and more. So there's a lot of money to be made in the space economy, especially with the data, not so much with the launch and the rockets and the technology design. There's some there, but it's in the data.
And the monetization of data. Understood. Do we have time for more questions? Okay, so what are the first steps a student can take in order to try and design or replicate a CubeSat using CAD software? It's a technical question.
Do you want to have a go at that, Hubert? Do you want me to? I mean, I thought you'd say that. Yes. Yeah.
I'm not a scientist.
Well, first step student could take to try to design, replicate. Well, if you want to replicate something, you get an existing design off the web. You just try to learn how to use the software to draw this, to render that, to put the component here and do all that. So that's just like learning, a learning process of how you use a modular system like a CAD design software. Many projects out there, you get one, you learn how to use it, you become an expert, and you can render anything. It doesn't have to be a CubeSat, it can be a machine, it can be a motor, it can be a CubeSat. That's the first thing. Now, the question has disappeared, so I can't actually see the first part of the question. The steps to if you want to design something, you design something if you've got an idea. If you have the skills in the CAD to know how to render it, then it's how you put that idea into an object, how you render it. So that's where the tricky part is, converting your idea into a rendered thing that will satisfy all the CubeSat restrictions on space and, and size and everything else.
Got it. And I actually have a personal question. For me, I definitely see the value, the educational value in going through the process of developing a CubeSat, whether I'm a university student or a secondary school student. But what kind of tangible skill sets will I gain from that experience that will prepare me for a future opportunity in the workforce in the space industry?
Well, maybe I can.
You have a go, yeah.
To manage a CubeSat process from beginning to end, you see an idea, and the idea often starts out as a dream, and it becomes an idea, and it becomes a mission. And to gather the forces involved, all the different talents and resources to work together on this kind of project, right? And to see it from beginning to end, whether the project takes 2 years or 3 years or 5 years, and successfully conclude. So many activities in the world now are governed by technology adoption and creation and so forth. And so to see that process as a student really enables you to be ready for the new economy, right? Where it's going to involve things like 3D printing, Internet of Things, smart city. So CubeSats are very much part of smart city, and it really trains you to think not just of using the technology, but also how it's made. I think that's very, very important. And it will also get you, for example, cybersecurity and data privacy are very important issues now. And so when you deal with satellites, that's a very, very important issue.
Got it. Understood. We have a couple other questions that have just trickled in. This is a good one. Will Hong Kong's space economy be more China-centric and less international due to the national security nature of the industry itself?
Maybe I'll try to answer that one, although welcome, Professor Parkers. I think Hong Kong has a very unique position as a kind of gateway between East and West, and it's always kind of had that position. And if you think of the 170-year history of Hong Kong, through various different political situations, it's played that kind of role. So it's in a new situation now, and I think people here are going to adapt and try to be productive economy, even though it's going through all this you could say political change. And I think space is something that has very many academic, scientific commonalities and a commercial potential. And so that's, I think, the focus of Hong Kong.
Awesome. I think we have time for one more question. This individual asks, what do you think are the potential applications or prospects for local entrepreneurs in SMEs in the context of space and the future opportunities in the global space economy?
Well, we're launching a top postgraduate master's in space science at Hong Kong University. We tried to launch it last year, but with COVID and everything, we decided to postpone it for 1 year. But the reason we're putting this program on is because we really believe that the space economy is a very important part of the new global economy that's emerging. It's a big new component of the global economy in all sorts of different ways. Hong Kong can play a very major role, I believe. And because we're partnered in with the strongest groups in the mainland, there's lots of internship opportunities. So what people on the master's program do, will be able to have interns in some of those partners I mentioned, but not just in the mainland of China, within the LSR itself for Hong Kong U, perhaps within OASA and Hong Kong UATG as well, but also in Padova-Sisas, Natural History Museum, and some of the other partners we're building. We're actually, at the moment, looking at establishing an MOU with the European Space Agency. And that is important because various issues, it's hard sometimes for the mainland of China to deal directly with some of these entities like NASA, but Hong Kong can more easily. And so we can act as a kind of facilitator and as a gateway, as Hubei said, to some of these important connections. For me, it's all about building the trust to make, the scientists working together across boundaries, across frontiers, and building trust to make everything work better and everything safer as well.
Great. I think we'll be moving on to closing remarks. Thank you.
Thank you
for
very
your
much.
Questions, everyone.
Great questions from the audience. Thank you.
Yes, very good questions.
Yep.
So, am I up?
Yes.
So, thank you for your great questions, Kimberly. This has been a very enlightening session, and also for Professor Parker. We do want to thank, our audience for joining us. We welcome all your questions. There's a survey at the end of this video, a Zoom video, and so we hope that you will fill that out and help us understand what your needs are and what your dreams for space are, because we're trying to serve everyone in Hong Kong, especially the young members in the audience, and pursue your interests. So we'd like to help you satisfy your space dreams.
Hear, hear.
Great. Well, again, thank you everyone for participating this evening. I certainly enjoyed it and found this to be a fantastic introduction, again, to CubeSat and OASA's mission in Hong Kong and beyond. I'd like to conclude with a couple of housekeeping points. As Hubie mentioned, it'd be wonderful if you guys could stay on after the close of this webinar to fill out a survey. It should only take a minute and it'll be completely anonymous. This will essentially allow us to plan for future programs and make sure that they're aligned with your areas of interest. It should populate automatically on your screen. And then secondly, OASA and the Wave will be hosting their second webinar on the 5th of January, which is a Tuesday at 5:00 p.m. Again, that's Tuesday, January 5th, 2021 at 5 p.m. Please mark your calendars. It'll be on the topic of 3D printing in space. All right, thanks everyone.
Thank you, bye-bye.